Hi, this is Mr. Casey, and today I'm going to be talking about equations. The first thing that we need to know about equations is that we have to utilize inverse operations. So I really hope right now you are starting to take notes. Okay, so inverse operations, we have addition. The inverse of addition would be subtraction. We have subtraction. The inverse of subtraction would be addition. So as you can see, these are our inverse operations, so they're interchangeable. And we also have multiplication. And that inverse is division. We have division, and that inverse is multiplication. So there are two types of inverse operations: multiplication, division, division, multiplication. So they are interchangeable. This undoes. So this is to undo each other. So addition undoes subtraction, subtraction undoes addition. Multiplication undoes division, division undoes multiplication. So let's go ahead and start with some one-step examples. What this means is that this is just one-step operations, so there's nothing more than just this. Okay? So let's start with our first one. We have x plus 5 equals 15. Now we need to look at both sides. We have a variable on the left, and we have a constant on the right. We want to move our constants from the left to the right. In order to do that here, we need to make sure we draw our river. I'm adding 5 here, so if I'm adding 5, I need to do the inverse. So the inverse of operation is subtraction. So I need to subtract 5. That cancels. Remember, what I do to one side, I have to do to the other. Now I've got 15 minus 5, which gives me, these cancel, give me 0, and then just bring the 1 down, 10. So my answer is x equals 10. So what inverse operation did I use here? Addition to subtraction. Number 2, our second example. We have 3x equals 21. So I have 3 times x equals 21. So 3 times, I'm multiplying. So remember, if I'm multiplying, the inverse operation would be division. So I divide by 3. Remember, draw your river. What I do to one side, these cancel. I have to do to the other. So 21 divided by 3, x equals 7. So my answer is x equals 7. What inverse operation did I use? Multiplication to division. Okay. We got example number 3. Example number 3 is x minus 3 equals 9. So here we have subtraction. So we know that my inverse operation of subtraction is addition. So again, we're going to draw our river. I have x minus 3. So if I'm subtracting by 3, I need to do the inverse. Remember, subtraction is addition. So add 3, add 3. What I do to one side, I have to do to the other. These cancel, because negative 3 plus 3 gives me 0. 9 plus 3 is going to give me 12. So x equals 12. What inverse operation did I use here? Well, I had subtraction, so subtraction to addition. And we have one more example. Our last example is x divided by 4 is equal to 10. Before we get started, remember we have a F word, which I do not like to use. It's just division. So x divided by 4. So if I'm dividing by 4, remember we got to go to division. My inverse operation of division is multiplication. So I need to multiply this side by 4. What I do to one side, I have to do to the other. Remember drawing a river. 4 times this was going to give me these to cancel out. So I'm going to get x equals 4 times 10 is equal to 40. So x equals 40. What inverse operation did I use here? Division to multiplication.